Hey class, this is Gigi from Kauai Community College. This is a video on L'Hopital's rule, and this has to do with taking limits. So this is another strategy for taking limits. Okay, so the L'Hopital rule says that if f and g, two functions, are differentiable on an open interval containing a, that means that it's differentiable around near a, right? And that the derivative of g of x is not 0. Okay, now when we are taking the limit of f of x divided by g of x, the limit of the fraction f of x divided by g of x, if they are of the form 0, 0, or 0 over 0, or negative positive infinity over negative positive infinity, any variation of that, then the limit as x go to a of f over g is the same as the limit of f prime of x divided by g prime of x. What it's saying is the rate of the function here, the ratio here of the function, is the same, really, the ratio of the derivatives. Not to be confused with the quotient rule. This is not the quotient rule, right? We are not taking the derivative of a quotient. We are saying the limit as x go to a of f of x divided by g of x is going to equal to the limit of x goes to a of the derivative of f divided by the derivative of g, provided that the derivative of g of x is not 0, because we cannot divide by 0. Okay, so the only scenario where you could apply this rule is if it's in the form 0 over 0 or variation of infinity over infinity. Now, there are some other forms that are what we call indeterminate forms, where you can actually transform the way these things look into these forms, right? You need to turn them into those forms first so that we can apply the L'Hopital rule. Okay, so these are the ones that are indirect application of the L'Hopital rule, meaning that you have to transform the way the expression looks so that it's 0 over 0 or infinity over infinity to apply the L'Hopital rule. Okay, now what does it mean to apply the L'Hopital rule? So example here, the limit as x goes to 0 of sine x over x. So when x is approaching 0, we have the numerator is approaching sine x, which is going to go to 0, right? Sine of 0 is 0. And then x here would go to 0. So we have the form 0 over 0. Therefore, L'Hopital rule will apply. Okay? And so what L'Hopital rule will say is that the limit as x goes to 0 of sine of x over x is going to equal to the limit as x goes to 0 of, and we will say take the derivative of the function f, which is cosine of x, divided by the derivative of x, which is 1. Okay, now we can go ahead and do the calculation. So then this is going to be direct substitution. Cosine of 0 is going to be 1, and then we have 1 on denominator, so this limit goes to 1. And I think we have done this before using a table of values, and we know that it is approaching 1. However, now with L'Hopital rule, we are able to make a complete calculation of it. Okay, so again, L'Hopital's rule says that if we have the form 0 over 0 or infinity over infinity plus or minus, right? Then the limit as x goes to a of f of x over g of x is going to be the limit as x goes to a of the derivative of f divided by the derivative of g, not the quotient rule. Okay, here's another example. Taking the limit as x goes to infinity of e to the x over x squared. So when looking at this here, when x is very large, e to the x is going to be very large, and so is x squared. So this is of the form infinity over infinity. So L'Hopital's rule will apply. So then the limit as x goes to infinity of e to the x over x squared is going to equal to the limit as x goes to infinity of the derivative of e of x, which is e to the x power, derivative of x squared, which is 2x. And so when you get to here, you're like, okay, well, when x is going to infinity, the numerator is going to go to infinity and the denominator is going to infinity. So we have the form infinity over infinity. We can then again apply the L'Hopital's rule. So this limit is going to be limit as x goes to infinity of e to the x power divided by the derivative of 2x is 2. Okay, now we can go ahead and evaluate that because the derivative, when x goes to infinity, e to the x is going to be positive infinity. Positive infinity divided by 2 is still going to be a very large number. Therefore, the limit is infinity. All right, now why can't we apply L'Hopital rule here again? Because it's not of the form 0, 0, 0 over 0 or infinity over infinity. There we can just go ahead and make judgment to say that a big number divided by 2 is still a very big number. Okay, next we have something like this, right? Now previously, we have done this problem by this method. And we are, before L'Hopital rule, we say divide everything by the highest power. So we're going to divide this by x to the 4th power over x to the 4th power, right? And we are relying on the limit of x goes to infinity of 1 over x is going to 0. Okay, so here we have 3 minus 5 over x squared divided by the denominator will be 5 over x to the 3rd minus 6, right? And we're saying when x goes to infinity, this goes to 0. This goes to 0 because a number divided by something very large is going to approach 0. Therefore, this limit will be 3 over negative 6, which is negative 1/2. Okay, so that's what we had done before. Now, here, we can think about this to say, oh, look, when x is really big, x to the 4th power is going to be large minus something smaller is still going to be very large. And then negative 6x to the 4th power will go to negative infinity. And we pay attention to the higher power because that's going to be a lot more, right? It's going to behave like the x to the 4th power rather than the x squared or the x. So this is of the form infinity over negative infinity. So we can apply L'Hopital rule there. So when we apply L'Hopital's rule, we would say x goes to infinity of the derivative of the numerator, which would be 12x to the 3rd minus 5x, not 5x, but 5 times 2 is 10, divided by 5 minus 24x to the third, right? Now, here again, when x is very large, we have x to the third, which is a big number, divided by the bottom, negative 24. X to the third is a negative big number. So again, it's of the form where I can apply L'Hopital rule one more time. So then we will have limit as x goes to infinity of 36x squared, and we don't need the fraction to be that long because that is it on the numerator. And on the denominator, 2 times negative 24 would be negative 72x squared, right? And when we reduce, we will get 36 goes into 72 twice. So this is going to be x squared over negative 2x squared, and we can say that we can go ahead and reduce the x squared divided by x squared as well. So that is going to be limit as x goes to infinity of negative 1 over 2, which is negative 1/2. Now, if you didn't buy that reduction right here, you can apply the L'Hopital's rule one more time, and when you do that, that will be limit as x goes to infinity of 2x over negative 4x, which then you can say, oh hey, I can apply L'Hopital's rule one more time because it still is infinity over negative infinity. And when you do that one more time, you'll get 2 over negative 4, which again reduced to be 1/2. And that is the same answer as if you have done this method here that we have learned before at limit at infinity, right? When you learn about limit at infinity, we would rely on the fact that the limit as x goes to infinity of 1 over x to some power is going to 0. So some form of that, so we divide by the highest power. Now, you may be asking me, why do you use L'Hopital rule when what we have learned before works just fine? Well, it's up to you. It's your job to decide which one is the appropriate method to use.